and welcome to the first ever live edition of Lexx Education. Ron and I are in the same room.
Hello, and we have a live studio audience.
Hello studio audience. It's girlfriend of the podcast, Judith, and Tom.
Husband of the podcast.
Also, if you watched the cornflower experiment, that was Tom in that. Hello, Tom.
Hello.
Hello, girlfriend of the podcast, Judith.
Hello.
We're all reunited because happy 70th birthday, Dad. What?
Father of the podcast.
Father of the podcast, Howard, turned 70 in November, but we are surprising him in August, so that's exciting. Welcome to the show episode. Thank you to PodSpike, as ever. We always start the show with a big thank you to PodSpike, who got us going with, you hear what we're like. Do you think you'd be listening to this if it had been left to us to market it? No, you wouldn't, because we like to be nonsensical. We don't have a marketing plan, but PodSpike really helped us with launching. So if you are doing a podcast or thinking of doing a podcast and you're like, I don't know where to start, talk to PodSpike.
Even if you're doing a podcast and you think you're doing all right, still talk to them. They'll get you more on track.
Yeah, even if you don't want pod marketing help, just hello, Dan.
Yeah, they're nice.
They're really nice people. And Suji. Hi, Suji. Anyway, so that's PodSpike. We've got some thank yous to you, the lab rats. Obviously, thank you so much, Stephen, for my top trumps. Ron, I was at stage at Green Man Festival, and then Stephen, sitting in the front row, surprised me with a present wrapped up in the same colour purple as Dairy Milk chocolate. So I thought he was giving me a chocolate bar. No. It was some chemical element top trumps.
Well, where are they?
They're in a bag over there. We're taking them this weekend to play.
Oh, okay, I feel like we should have had them for the episode.
Do you want me to go get them?
Yeah. Do you know where they are?
No. You said they're in a bag over there.
Yeah.
Be more specific about the bag and the over there.
They'll be in my pink Kate Spade, but second-hand, handbag.
I think I saw that earlier.
Stay tuned till after the episode and we'll play some top trumps.
The studio audience have now gone off on an errand. So thank you, Stephen. We love you very, very much.
Joe sent us a song about blood, which was by...
They Might Be Giants.
They Might Be Giants. So I've been on a Malcolm in the Middle nostalgia kick.
Oh, is that what the...
Yeah. Yes, no, maybe, I don't know. And then I did loads of research into them because I was like, are they a novelty band? I didn't really do much research about blood. I was looking into them. Are they a novelty band? No, they just did a science album for kids, just for the kids, just to help out the kids. Yeah. Nice boys, I think. They
might be nice guys. Oh, it wasn't in that handbag. I'll find it during the episode. Goulash has waded in on the sugar in tea debate. It's not really a debate, is it? We just decided sugar in tea is bad. That's done.
Drink tea how you like, listeners. Enjoy your life.
Boo. Squirrely Birrely wants merch that says magnets on the front and don't just say stuff on the back.
I think that t-shirts that say "Don't just say stuff" would be quite a universal sell. I think that would go well.
Yeah, I mean it does work in all aspects of life.
People don't want people to just say stuff.
Oh, we got a laugh from the studio audience. Other thank yous this week to Matt, Jeff, to Jenny's, Kay, Emma, Stephen, and the podcast Just Films and that. Thank you very much for recommending us to all your followers. That's very lovely of you. We're very grateful. And thank you to Becky and everyone else who got in touch. We're very grateful to you guys for being as interactive as you are. We very much look forward to Mondays now, don't we, Ron?
Yeah, it really, we're two anxiety-ridden, stressed-out people, and it's really taken sort of the
sting out of being alive.
No, I was going to say the anxiety out of putting something out there, because everyone's very nice.
Yeah, so we're chemistry this week.
Yes,
yeah.
The noble gases.
Yeah, it's all right this one, isn't it? We don't get too mad at each other.
There's a bit of a revision in this one. It's all fairly cordial, although there's a lot of you asking for extra context, which you then refuse.
Enjoy! Now listen, so we did biology last week, it's chemistry this week. I don't have my periodic table with me because I'm in Norway. Is it going to be about periodic table?
It's going to be a lot about elements, but if you just Google periodic table,
I want my periodic table though. I've got
Google's
used to mine.
They're all the same, that's kind of the point. Google's got a very nice interactive one that you can use.
What?
Yeah, and it's got
Interactive?
little spinning pictures of all of the elements.
Spinning?
Yeah.
Where do I get that from?
Google.
What do you mean Google? What do I Google? Just periodic table?
Yeah, that's what I said. This is not a good sign.
Spinning. How do I make them spin?
Click on one of the elements.
Yeah.
Should appear on the right hand side and then give you a little picture.
Chromium is just having a little dance. Looks like a blueberry.
Yeah, and you can grab it and move it around yourself.
Only if it says yes. Oh yeah, look, there's its force fields. Alright, okay. Oh, I do miss my periodic table though. My one's nicer.
Shouldn't have forgotten it.
It's been a stressful week. But you know what? It's a lovely day in Oslo, and I think by tomorrow I'll be able to walk again. I'll be able to see it. So, good times. All right, I thought we'd learned everything about the periodic table now. Didn't we do that last week?
Yeah, we learned a lot about the periodic table. Now we're going to learn about specifically some elements.
Ooh, we're getting down and deep with some guys.
Yeah, I mean, a lot of this is going to be sort of... we've gone through a lot of the concepts that we were going through today, but that's just because I'm a fantastic teacher, so I've kind of added context as we've gone along. But we're going to go into a bit more detail and some specific groups, okay?
Okay.
So the first thing that we're going to talk about, and you, have talked in previous episodes about metal bananas. Is potassium a metal? What is a metal? Is there metal in your blood?
There is. To all those questions, yes.
Yes. So the first thing that it wants us to learn is what is a metal, what is not a metal. What do you reckon?
Things that are metal, and things that aren't metal.
Do you want to try?
What do you mean?
What do you think a metal is?
That's metal, isn't it? What do you mean? What do you mean, what's a metal? Like screws, they're metal.
Yeah, but what? No, so screws will be made out of, I think, usually nickel. Nickel alloy.
Yeah.
What makes nickel a metal?
Somebody told me it was a metal. This is your catch me out science here, because no such thing as a metal, probably. It's just whatever got called a metal.
No. So, simply put, elements that form positive ions are metals. Elements that do not form positive ions are not metal.
What's an ion?
You know what an ion is. Come on.
An isotope?
No.
Magnet.
An ion is an atom that has lost or gained electrons, so it has a charge.
Okay, so what was a metal? An ion that's positive?
An element that forms a positive ion. So, for example, sodium, that we've talked about before, it loses its electron. It forms a positive ion, thus is a metal. Okay? Chlorine gains an electron, therefore forms a negative ion, not a metal. You're going to need some emotional resilience because this is so easy and you look like you're about to start crying.
I'm not saying it's not easy. It's just that why is what you are dependent on what happens to you? So how do you know what it is when it's just in its normal state?
You investigate and you find out what it does. And you don't just posit a guess from a mile away.
That seems irresponsible. To not just take things at surface value. I'd hate to be judged on how I've reacted instead of just how I was before something provoked me. Do you know what I mean? No. Is it a metal before it's lost its ion then?
Yes, it's an element that forms a positive ion. It is not necessarily a positive ion. But there is a reason for that, but we'll go into that later on.
Oh, good. Can't wait.
Next week, or next chemistry, be cool.
I'm being cool.
You're not being cool.
Well, you've just jumped straight in with some radioactive nonsense, and it...
Radioactive nonsense? You're the one that was banging on about metal bananas. I thought you might be interested to find out how and why these things were classified.
Yeah, I am interested, but it just you can't get mad at me when I don't know it straight away. Otherwise, it'd be the world's most boring podcast, wouldn't it?
I didn't get mad at you because you didn't know it.
You did. You said I had to buck up or whatever you said.
I said you needed some emotional resilience because you got so sad after I said that to you.
Because we just did the quiz for the last episode and I got it all right. And then the problem is we do a quiz and I've learned something and then we have to go and learn something new and I don't already know this.
Yeah.
Also, I can't feel my baby toes. The feeling hasn't come back to them yet. Do you think they're going to fall off?
Maybe, that'd be cool. Then you'd be like the Simpsons.
Yeah, that would be cool. All right, so everybody that's just got like an extra sad boy is a metal, and everybody that's got a good party that attracts a sad boy is a... Why are you shaking your head?
Oh, because I thought you meant, when you said extra sad boy, I thought you meant as in the ones that attract a new sad boy.
No, they've got a spare sad boy. If you've got a spare sad boy that wanders off, you're a metal.
But it's not spare though, because they're still equal to the number of protons.
Yeah, but it looks spare, doesn't it?
Yeah, the ones that lose sad boys are metals.
They're
The
metals.
ones that gain sad boys or don't react are not metals.
Okay, so how can we remember this? It's like a metal band, and the drummer has gone off somewhere else.
Can't we just remember it as that?
No, we physically can't. Because, Ron, I've clearly already learned this at some point in my life, and now you're talking it at me, and it is like you are explaining that the grass has always been on the ceiling, and I'm supposed to have known that. It is baffling to me that anyone's ever said half these words to me before.
I don't know though, like, we didn't go to the best school.
Yeah, but
like,
I
might have just been like, ooh, cows are an element. A star! Well done, Laura. Off to drama school.
Okay. And then everything else is not a metal.
Yeah.
All right, okay.
Okay, and that's it. That's all we need to know on that issue.
We're done?
With the metal versus non-metal thing.
Okay, you explain the next bit. I just need to reply to a text message.
Okay, well, we're learning about some groups of elements today, aka up-downers from last time.
Yep.
The first one that we're going to learn about is Group 0, the noble gases. I have in my notes, leave space for Laura to do an impression of a noble gas. Alright, do you want to tell me about noble gases then?
The noble gases are very
hands on the back of my
stable.
head.
They're very stable
Why?
because they have very full outer rings.
Yes, their outer rings are completely full, so it's very hard for them to lose or gain electrons, which is why it's safe to even let children inhale them, because they just don't react to anything.
And you can make lights out of neon.
You can. You can actually make lights out of all of them, which leads me on to this picture that I'm about to send you.
Ooh, I like a picture round. You said it's very hard to get them to lose or gain one. How can you force it?
So, with all of these things, it's about energy, right? So, if you applied enough energy, you could get something like that to happen. But it's just the chances are that in nature, like not under sort of scientific circumstances or something, that amount of energy will never be concentrated into one place.
Got ya.
Send the picture, goddammit. It's not letting me do it.
The rumbling makes it sound like you are trying to physically post it to me.
Oh, sorry. I need to burp. You really threw me off with your reaction to that first bit. I'm quite sad now.
Why are you sad? I've done so much listening.
Okay, I've sent it to you.
Got it. Ooh,
See?
So Ron's just sent me a picture of different lights made by the different noble gases. So helium makes like a pale purple light. Neon, but neon lights can be all sorts of colours, can't they? I suppose you just change the
colour
glass
tubes.
around them. I see.
Yeah.
Neon's making like an orangey light, maybe with a bit of purple in there. Argon is making a dark purple light. Krypton is white light. And Xenon is blue. Pretty.
Yeah, so like all of these groups that we've talked about before, the properties are all the same, but then, you know, either increase or decrease as you go up or down the group. So one of the things that it wants you to know about is because of the relative atomic mass of the different gases as you go down the group, the boiling points of these gases changes as you go down.
You can't boil a gas. How do you boil a gas?
I have in my notes, because I knew that you were going to say that. Yes, they are all gases, but gases still have boiling points. But those boiling points are just at temperatures that we don't come across in our daily lives. So helium,
What does a gas turn into when you boil it?
A gas.
It goes into another gas.
No. So helium, the party gas, its boiling point is at 4.2 Kelvin. Do you know what Kelvin is?
Is a temperature. It's a temperature. Yep.
Yeah.
It's the SI unit of temperature.
It is.
Yes.
But do you know how why it matters or what it is? So centigrade, which is the one that we use most of the time, right? Centigrade is based around water. So 0 centigrade is the freezing point of water, 100 centigrade is the boiling point of water. That's how it was worked out. It was just that temperature bracket divided by 100. Kelvin is done from absolute 0. So you need to react like I need some kind of affirmation.
Look, you say something like absolute 0, like that means diddly squat. What is absolute 0?
So absolute 0 is the point where every substance has no heat energy in it.
Okay. Who's got the lowest one?
The lowest what?
So that must be one element's freezing point. Do you know what I mean?
Yes. So that I think is hydrogen, but I might be wrong.
Okay, cool. All right.
So 0 Kelvin, absolute 0, is about minus 272 degrees.
That's very cold.
Very, very cold. So the boiling point of helium...
How do you even get something that cold?
I don't know. Super fridges, I think. The boiling point of helium is 4.2 Kelvin. So that is minus 268. So before that, colder than that, helium is a liquid, and then it boils into a gas, right?
No way.
Yes way. And then we have neon, the tube gas. 27 Kelvin is the boiling point. That's minus 246 degrees Celsius. Argon, the bulb gas, is 83 Kelvin. You see, it gets bigger and bigger.
Yeah.
And then I found some other uses for the other gases. Krypton,
Killing Superman.
used in lasers.
Ooh, to kill Superman.
And then xenon, right, according to Wikipedia, used as propellant for ion thrusters. Because apparently now we live in science fiction movies.
What's an ion thruster?
Fuck knows, but it sounds cool.
Yeah. Xenon Warrior Princess is one of my favourite gas-based hero stories.
And radon is leaking out.
I would
the
like to
rocks
see
in
some
Cornwall.
fan art of Xenon Warrior Princess, please. One of our listeners must be creative. Please draw Xenon Warrior Princess.
And radon is just leaking out the rocks in Cornwall and killing people.
Is it?
Yeah,
Why?
because it's in the rocks and it's radioactive.
Radioactive. Why is it in the
You
rocks?
can't do that every time we say radioactive. You simply must stop.
What if I don't want to? I'm getting fewer and fewer chances to join in the more complicated it gets. So I think singing radioactive is a perfect use of my time.
It's in the rocks because that's where it is.
Ah. Sucks to be you, the Cornish.
Yeah, it does. Like Cornish people often will have radon detectors in their basements and stuff. And my friend Ross, that is from Cornwall, has told me before that there are like theories that's why Cornish people can be a bit weird sometimes because the radiation is just getting to them.
mean, having met your friend Ross, I don't disagree in his case.
Did I tell you about the most Cornish man ever that I saw when we were in Cornwall last September? We were having like a nice brunch at this little cafe sat outside, and there's these three guys that have all got farmer tans and really, you know, when old men in the countryside just have really worn baseball caps? Mm-hmm. Yeah, it's those kind of guys. And one of them goes, "There's only one good kind of rapper, a sweet rapper." And the two guys with him lost it. They were laughing for so long. Oh, it was brilliant. They were so red in the face. I loved every second of it. Right, that is Group 0. Oh, the other thing that I wanted to say, you know, so helium makes your voice really squeaky when you're inhaling. Did you know that changes with the mass of the gas? So if
I didn't know that. Oh.
If you inhale Xenon, it makes your voice really low.
Oh.
Yeah. So if you inhale Xenon, it's like, you know, come out all Darth Vader.
So that's Group 0, even though it's all the way over the right-hand side. Well, that doesn't work for me.
Yeah, I don't really know why it's like that, to be honest.
I suppose it makes sense. I suppose, is it Arabic and Hebrew you write from left to right?
Maybe. I don't know about Cyrillic though, because if it was Mendeleev.
Peas.
No. Okay, right. Next up, we're going to do Group 1, which we've already done before, so we're not going to spend super loads of time on it. But I just wanted to sort of head back, reconfirm, in your own words, in your own time. Can you give me a rundown of the properties of Group 1 and how those change as you go down the group?
Yes. Which one are we calling Group 1 on this periodic table? The one next to Group 0?
No, there should be one labelled Group 1, no?
No, because this periodic table's stupid. It doesn't have any numbers on it.
Oh, the Alkali Metals, so lithium, sodium, and that bunch.
Let me think. Is it something about a cheese knife? Why am I thinking about a cheese knife?
Fuck knows. Fuck knows, honestly.
Is it, you can put them in water, those ones.
Can.
And they all do different things in the water. Some of them get a bit farty. Some of them go fire.
Start at the top of their group. What do you think lithium does when you put it in water?
Relaxes. Bobs about a bit. Has a lovely day. No.
Yeah. And then what does sodium do?
Dissolves.
No. Well, slowly it does, but...
Farts about a bit.
Yeah, farty bubbles, it sort of bimbles around at the top. Potassium starts catching fire. And
Yeah. I said all this. Yeah.
No, you're being quite flippant.
Sorry, I was being flippant about your girlfriend. So yeah, they do that. It's something about cheese knives.
No, they're soft. They're very soft metals.
Is that all it is?
Yeah, we didn't even mention cheese knives last time we talked about
I think
this.
I was picturing, you can cut them.
Yeah.
Yeah, and I was picturing doing it with a cheese knife. There we go, that's what it is. They're soft, and you can cut them maybe with each other, probably. Very soft, reactive, very reactive. What else do I have to say anymore?
No, that's good. I thought
okay.
you might. I wanted you to maybe talk about why they're really reactive a little bit.
Because they're metals, so they've got an extra sad boy. They've got one loose sad boy far out on a lone ring away from the magnetic pull.
Yeah, so why do they get more reactive as you go down the group?
Because there's more sad boys filling up the rings, so the lone sad boy out on his own is very far away from the magnets.
Yes, okay, cool. Right, yes, good job. So what we're going to do now is you're going to predict and work out...
What?
Are you supping from your bottle right now?
It's just a little bit of water.
It's very off-putting.
Sorry, I'm trying to keep hydrated, to keep my nephron active.
So you're going to You're going to predict some reactions for me.
Okay. Shock.
We're going to stick...
Or surprise. Delight. Fury. All good reactions. Thumbs up emoji.
You didn't predict the disappointment.
Oh, I know
You
you're
reacted
always
to that.
disappointed.
We're going to stick with our good friend Chlorine. And we're going to start
Oh,
with...
the hotel opposite mine is one of those cool window cleaners, like scaling down.
Oh.
Also, I tell you a cool thing about Norway. The breakfast just has as much salmon as you can eat.
Have I told you about the campsite that we're going to with some friends next month?
No?
I was left to book the campsite for the Eindhoven leg of our road trip, and I found one that's on a working trout farm. So on the website, like the third thing that it says is, we are quite often smoking and feasting on trout, which I'm very much looking forward to. Okay, back to this. Okay, cool. So, as I said, we're going to start with our good friend sodium, and we're going to start with a reaction that you know the answer to already. Okay.
Does it make salt with chlorine?
Yeah, so that's what we're going to do. We're going to talk about sodium reacting with chlorine.
Okay.
So chlorine, as with all group 7 halogens, we'll come to them in a second, exists as a gas, or when it's just chlorine itself, in little two-tours. So 2 chlorines bonded together, okay?
So you never have a lone chlorine?
No, not really in nature, no.
How is there always enough? How is there always an even number?
Just works out. So, you know what it will form in the end. Can you talk me through this reaction? What happens?
Yeah, go on.
Yeah, go on then.
What do you mean? What do
Can
you mean by
talk me
this
through
reaction? What reaction?
Sodium and chlorine.
Yeah, they make a pair.
Yeah.
And it's delicious.
Talk me through it. You know what happens.
Yeah, they make a pair. I have said that twice now, as I understand it.
No, tell me about it.
What else can I say? They join up.
Like, talk about the electrons. Something.
One of them goes to the other one.
We've got 3 of these to do.
Yeah,
so-
and I'm trying. Stop staring at me like I know what format you want the answer in. With that, right, sodium's got 11 and chlorine's got... Nope. 17. So probably a sad boy off sodium goes and sees chlorine.
Okay, so is it going to be
Hang on a minute, how do they stick together then?
Because they're attracted to each other. One of them's positive and one of them's negative. But, as I've said, chlorine travels around in a little pair. So, it's not going to be just one sodium atom reacting with the chlorine, is it?
No, there's going to be a real jealous chlorine.
Yes, so the equation that you end up with is 2Na, 2 sodium, plus Cl2, a chlorine molecule, equals 2 NaCl. Right?
It's like we're having a chat and then you just do a little triple jump. Just, hello, this is number 1. Foop-ba-da-boop-boop-boo, I've made a hat. It's like, you need to talk through all the process stages of making a hat before we get there from number 1. So it's 2 sodiums get involved in the chlorine.
Because there are 2 chlorine atoms in a chlorine molecule.
I thought maybe one of the chlorines would go away.
No, so when you do reaction equations like this, you always have to balance them so that they work.
Yeah.
Okay? As I say, we've got 2 more of these to do, so buckle up.
Well, how the hell would I know that chlorine's in a 2?
Because I told you that.
Yeah, but how would I know if I was a science and you weren't telling me? A scientist and you weren't telling me?
I don't know, they've worked it out at some point.
How would I work that out on my own accord, though, if that was a question?
You don't have to, I've told you that.
But what if it's in an exam?
work out chlorine? That's not going to be a question. We're doing the syllabus. I'm not just pulling this stuff from nowhere, mate.
What if the question was, how does a chlorine and a sodium react to each other? How would I know that they were in a 2?
You'd know.
How?
Because I've told you. That's the purpose of learning.
So I've just got to memorise all of the ones that come in a 2?
No, there are specific ones that you have to know about. Chlorine's one of them. But that's like saying, how am I supposed to know that sodium loses a sad boy? Because
I
I've
look
told
at
you
it
that.
and I see the extra sad boy.
But you didn't know what a sad boy was 12 weeks ago when we started doing this.
No, and I'm still referring to it as a sad boy rather than whatever it actually is.
An electron. Yeah.
Oh.
So I don't know why this extra piece of information is
Because
the
that
bridge
feels
too far.
arbitrary, and that's just a thing you have to know. That is stupid. If it's going to be science, it needs to be so logical you can work out the whole thing itself, or it ought to be a different thing. It needs
Do
to
you
be
want
some
to
sort
know
of...
why it works like this? Because I think this is going to fuck you off, but I will tell you.
How could I know that without knowing it?
I can tell you.
Yeah,
I can
tell me
you.
then. Why are you being so horrible today?
Because you are cantankerous.
Yes, I'm tired and sad and broken.
Right. So, we will come to this later on, we just have not yet. Molecules are formed when atoms...
What's a molecule again?
You interrupted my fucking definition to ask that.
Okay, sorry.
Molecules are formed when atoms create covalent bonds between each other.
It's covalent...
Don't ask what a covalent... Don't ask. I'm about to explain it.
Molecules... What are molecules? Molecules are when
When is a structure made by covalent bonds. Now, I'm about to define what a covalent bond is, right? So, electrons,
No,
when
I'm
they
thinking
are...
of concave.
Electrons, when they are whizzing around an atom, they like to be in pairs, okay?
Me too. I hate to be alone.
Yes, we all do. Being alone is the worst. Electrons like to be in pairs. Chlorine, as you know, has 7 electrons in its outer shell, okay?
Yes, sir.
So that means there's 3 pairs, and then 1 on its own.
Aww.
So when it's reacting with chlorine, the one on its own from one chlorine and the one on its own from another chlorine form a pair. That is a covalent bond, and then that is why they travel around in a 2, because 2 of their little outside whizzers are hanging out.
Yeah, makes sense.
Okay?
Yep.
So, then we move on to our formula. So the chlorine's going around in a 2er, okay?
Yeah.
So then we need 2 sodiums to react with that, because...
Why does the chlorine still want to react if all the pairs are happy?
Because it's better for the chlorine to fill its out, because they could both fill their outside rings if they steal these electrons from the sodiums.
Okay. So it's a bit of an unhappy sort of marriage of utility, really, isn't it?
There's actually very little emotion flying around.
I think that's my problem with a lot of science, is that I can't help adding emotion to the situation. I just give them all personalities.
So the next one that we're going to look at is oxygen reacting with sodium.
Sometimes when I edit these, I worry that people think I've edited a bit out when there's just a pause and then you move on. And I hope people know that that is just actually how the conversation goes. I say something very profound and then Ron just pauses for a second and carries on.
Yeah, sometimes I worry that I've edited out too much of the thinking time and people just think you're getting it a lot quicker, and then I'm just being really rude to you. Because like sometimes I edit out like
He
30...
is.
Sometimes I edit out like 30 seconds of like and then you say something and I'm like, no, you idiot. Anyway, okay. So oxygen also exists as a pair.
Yes, O2.
Yep, O2. Oxygen has 2... if you want to learn about this as well, oxygen has 2 covalent bonds between it because it has 2 single boys on its outside. So then the 2 single boys of one oxygen hang out with the 2 single boys of the other oxygen. It forms 2 covalent bonds between the oxygens. Okay?
How can I have 2 single bonds on its outside? That's a pair.
It's to do with the way that the electron rings are made. They come in different shells. It's a whole thing, and it's an A-level thing, and I'd rather we just didn't, okay?
Me too, mate.
Can you please, and I've gone for a piss, I'm feeling a bit more level-headed now. Let's do this together. Let's figure it out, okay? It's going to be a nice experience. But let's figure out what the balanced reaction will be between sodium and oxygen, okay?
Okay.
So let's think about it in terms of electrons. So how many electrons does oxygen have in its outer shell?
Stop spinning. 6.
How many gaps does it have in its outer shell?
Ron, it's spinning.
Oh, don't count them. Use your memories and knowledge. Also, you can't count gaps.
I can count gaps. Do you mean the gaps in between the electrons?
No. How many electrons is it missing from its outer shell?
Oh. 2.
Oh, you've just gotten super loud.
How about, is that better?
Yeah, it's a bit better, but no, don't shout.
2?
Okay, yes, that is correct. So, for sodium to fill those, how many sodiums would you need?
So sodium's got 1 sad boy in its outer ring, so you'd need 2 sodiums.
Yep, but oxygen travels in a pair. So what would the balanced reaction equation be?
Well, 4 sodiums then.
Plus?
4 more?
No, 4 sodiums plus O2 equals...
Hey! Happy days!
So when sodium and chlorine reacted, we got NaCl, didn't we?
Yeah, sounds like a university, doesn't it?
No, it just sounds a bit like UCl. Now, so if that's NaCl, and there's one...
And is it University of... There's like American ones, I'm sure, that are like University of California.
So, that's NaCl. What do you think the chemical name for what we've just made with oxygen, sodium oxide would be?
Can you say that again, please? I wasn't listening.
So, when we have 1 sodium and 1 chloride, we get NaCl. Yeah, so now we've got 2 sodiums and an oxide ion.
Yeah.
What do you think the chemical symbolness for that would be?
4Na O2?
No, because it's 2 sodiums per oxygen.
Yeah.
So it's going to be Na2O, but then there's 2 of them, so it's 2Na2O.
Huh?
One oxygen.
There's 4 NAs.
Yeah, but they come in sets, right? Because each oxygen reacts with 2 sodiums. So that's Na2O, okay? That's what that is. And then there's 2 of those. So it's 2Na2O.
Why don't you have to say that there's 2 O's?
Because you've already said that because there's a 2 at the beginning. Imagine it with brackets. So brackets around the Na2O, right? That's one thing. And then there's 2 of those. So there are 2
Oh,
oxygens.
I see. So you need 2 NAs for each O. Na, 2. And it's that little hanging down 2 on the bottom, isn't it? Like
Exactly.
A little tiny
Yeah.
line duck. And that adds up to 1 O. But you saying that that'll never happen on its own. It'll always be double.
Exactly, yeah.
It doesn't come as a single option. You've got to have the meal deal.
Yeah,
I
exactly.
don't know if you can hear that. I'm very sorry. The room next door is being serviced. There is a vacuum cleaner.
That's fine. Okay, the last one that we're going to do is sodium reacting with water, okay?
Sodium. Ooh, la sodium. We were just looking at it. Na. God, I wish it wasn't called Na.
Why?
Just because it doesn't sound like salt or sodium, does it?
No.
Say yes to sodium, not nah. Sodium's delicious. What else did you say? Water?
Yeah.
Wait, that is not going to be on here. because it is H2O.
Exactly. So what you need to know to work this one out is that when oxygen reacts with... when water
Henry
reacts
Cavendish.
When water reacts with stuff,
That's
it
who
splits.
discovered hydrogen, by the way.
When
In 1766.
When water reacts with stuff, it splits into an OH minus ion.
You can't, no, don't change it now. Let's just keep it all in the same way the others were.
What do you mean?
What are you talking about now? OH minus. Let's not learn those ones.
It's so hard when you interrupt me to ask me something I'm physically telling you.
I'm not asking you anything. I'm telling you not to teach me this bit because I don't think it's relevant.
It is, and it's fun. It's like a cool puzzle.
Fast and loose with the word cool there, Ron. I did a puzzle at the weekend. It was really horrible. It was like a princess with some dogs and some horses and a full moon and a castle. It was real bad.
So water splits into an OH minus ion and an H plus. Okay?
If you say so, Ron. You can't say that and then look at me like I'm being a dick when I don't go, makes perfect sense.
I'm really not trying to.
It's like me going, this bus splits into a Tuberon 960 and a Fluorine 8.
Well,
Got it?
no, it's not.
It
no,
is,
it's
because what does OH minus 1 mean?
You know what this week... Right. Right, okay. Cancel the rest of the podcast. We're going to talk about this now.
No, what does OH minus 1 mean?
Water is H2O. You understand what that is, right?
Yes, I do.
So it's 2 hydrogens and an oxygen.
Yes.
You know what minus and plus mean in these scenarios. It means that there's either got too many electrons or not enough. So have a think for a second.
Sassy.
What do you think OH minus means? Or what's in it?
I don't know.
An oxygen or hydrogen, and it's got a negative charge. OH.
Why is they switched around?
Okay, HO minus. It doesn't make a difference.
What do you mean minus 1?
It's got a minus charge. You call it OH minus, and
What? What's happening? Why have those two gone off on their own?
that's just a thing that I'm telling you. That's just how it works. That's what happens. Okay?
Yeah, I love it. It's brilliant.
I don't think you think it is brilliant.
You told me not to interrupt when you were explaining, so I'll just sit here.
No, I told you not to interrupt the question. The question about what I'm explaining. So, water splits into those 2 ions.
What was the other one? OH minus 1.
Just OH minus,
OH
and then
minus.
H plus.
H plus.
Okay? How do you think water would react with sodium? What's going to be attracted to each other? The sodium's going to lose an electron. It's going to become Na plus. What's that going to get attracted to?
You'd hope it would be the other happy guy, because I think it's unhealthy that the sad ones and the happy ones always get attracted to each other. It's pressure on the happy one. I'd hope that they would get off with the H plus guy and just go and have an adventurous life together. But I assume because of the magnet thing, it'll be sad one and happy one will hang out together.
Because of the lack of feeling of these submicroscopic particles.
Yeah. So it'll be NaHO, and then H plus will just dizzy about on his own.
Do you remember the farty bubbles?
All the time.
From when we were throwing sodium into water?
Yep.
That was hydrogen gas. So what you get is you get NaOH, and you get H2, hydrogen gas produced.
Why is he in H2 now?
Because they join up to make hydrogen gas.
OH is another 2er.
Yeah, so it's the same concept, because each H has just got one electron whizzing around it, shares it with the other H, covalent bond.
But sometimes that'll happen when there's 2 in the outer thing.
No?
Oh, I swear you said that earlier. I swear you said that about oxygen doesn't have a lonely guy.
It's got 2 lonely guys. Let's not go into it.
Exactly!
Yeah, but just trust me. Just trust me. You don't want me to get into covalent
I don't
shells.
want you to get into this bit.
Yeah, I know. That's why I'm desperately trying to get through this. Because also, I've just got to go back to work after this.
Me too!
Yeah, but like in a few hours.
No, I've got another recording in 45 minutes. Thank you very much.
Oh, I'm going to come out of this. I'm going to be so hot and angry.
I don't know why you're angry with me. I'm doing my best, but it doesn't make any sense, half of this. This one does this because the guy's lonely. All right, I get it. Oh, now it does it because even though there's 2 of them, they're not actually that close, so they're both still lonely, even though they're together. Remember that. Don't add emotions, though.
Yeah, but it's just you swerve wildly between being like, I don't give a fuck, who cares, don't tell me about this, to what? Why? Tell me exactly how this works, even though that's not part of the syllabus. Like, some things we just have to just learn.
Yeah, I did get told off for that a lot at school. Just learn it. Stop needing to know why to know it, and just know it.
Yeah, because it's like stuff like the covalent bonds, we'll get onto that, but just for right now, they just go round in pairs.
But then you look at me in some stuff and you go, but you should know this because I've told you why.
Yeah, because the difference with that is that with those things I've told you why. So the last thing that we're going to go through is group 7 or 17, which is the halogens.
Halogen.
This is your chlorines and your fluorines and your bromines and your iodines and your astatines.
I see. There they are over there by group 0.
They are highly reactive. We know why. It's because they have super attractive powers because they've just got one empty spot at their games table that one of the sad boys can come in and sit at.
Games table now, is it? All right.
Yeah, that's why I always think about it as it's like, oh, we've got one more spot at the table. Come in. Rather than with sodium, it's like one person sat at a table alone, and they're like, well,
But wait, they're over the right-hand side of the table, so shouldn't they be less reactive because they're further away from their magnets?
No, because that's up-down, isn't it?
Alright.
Remember?
It was left and right.
No. Same as the others. The boiling point goes up as you go down the group, to the point that bromine is actually a liquid at room temperature. It's brown, kind of a reddy brown.
Yuck.
As we've discussed before, they get more reactive at the top of the group. Can you remember why?
Closer to the magnets.
Closer to the magnets. That's what we want with these ones. And then the last thing that it wants us to know about group 7 is that...
Lay it on me. Come on, I'm going to learn this.
A more reactive halogen can displace a less reactive halogen from its salt in aqueous solution.
Jesus Christ. There goes another hop, skip and a jump. Also, I spent half of that sentence going, what's a more reactive subject? Before I realised you were saying the words more and reactive. This is a whole new breed I've not heard of.
So if there's some sodium bromide in solution, we can bubble through some chlorine gas, it will kick the bromine out, and then we'd have sodium chloride in solution, okay?
Okay.
Do you get it?
No, but you told me to stop trying to get it and just learn it. Play the tape back, Your Honour, because that is precisely what you just told me to do. To stop questioning it and trying to understand it and just say I understood it.
No, it's not.
It is.
No, it's just... you could question the thing that we're learning, but just not, like, going off on a tangent to understand something else.
All right, then. What are you talking about, Ron?
So, chlorine, more reactive than bromine, right?
Yes.
Let's say we've got some sodium bromide dissolved in some water.
Some sodium bromide.
Yeah, it's exactly like sodium chloride. The reaction is exactly the same because they've got the same outer shells of electrons.
When's it a
yeah?
chloride and a bromide instead of a chlorine and a bromine?
When they're ions.
And that is two of them.
No, it's two of them when they're in a molecule, so then that's chlorine gas or bromine liquid.
What's an ion? Is that when there's more neutrons?
When it's got a charge. No, when the electrons are off, when it's got a charge.
God in heaven.
So a bromide ion is going to be Br minus.
Yeah. So there's some chloride bromide in some water.
Sodium bromide.
Sodium bromide in some water. So
Some Sobro.
NaBrH2O.
Yep.
Okay.
That's floating around, having a lovely time.
Mm-hmm.
Then what we do is we bubble through some chlorine gas. So these are your Cl2s, okay?
Yes.
The chlorine is more reactive than the bromine. So
Loves
the
to start a
sodium
fight.
the sodium is more attracted to the chlorine than it ever was to the bromine.
Poor
Ugh.
bromine.
So the sodium goes and reacts with the chlorine. Now we've got sodium chloride. The bromines go, oh, I guess we didn't want the sodium anyway. They match up with each other and form bromine as would be in a liquid.
Incels! A little incel bro party.
Yeah.
See, isn't life easier when you give it emotions, Ron? This makes so much more sense when you explain it like that. Instead of because of numbers and magnets.
Okay.
Do you not think that this makes way more sense?
No, I really like maths. Maths makes so much sense to me.
No, it's too cold. There's no logic behind it. Whereas that is
There
like...
is all logic behind it.
No.
And that's it for the day.
I don't feel like we learned anything today.
There was a lot of shouting.
Yeah, so what have we learned today? Because honestly, I've made no notes because I haven't got my notepad. So just the quiz is going to be absolute disaster, I feel.
We learned what the difference between metals and non-metals are. We learnt about the noble gases. We learnt about group 1 elements. We did some chemical reaction equations. And we learnt about group 7, the halogens.
My God, it's going to be a bloodbath. We'll see you after the music. God, chemistry's getting worse and worse. We're back. It's 2 weeks later due to unforeseen scheduling issues. Ron, I found my notebook.
That's good, but you didn't make any notes in it last time.
No.
I think, I'm in a very good mood this week.
All right.
To subtly date the record for listeners, I've been listening to a lot of Mika, so that's been a mood lift. So I've been quite kind, I think, with the
Good, because I can't even remember what subject we did last time. 11. That must make it chemistry.
Twas
Right.
indeed.
Okay. Well, at least I can do maths like that. So, oh man. Okay. Jesus
Okay.
Christ.
Question 1 for 1 point. Wait, hang on. I'm going to say that there are 1, 2, 3, 4.
One day I'm
5.
going to make a montage of just you counting up numbers.
Oh, your hair's long.
Yeah, it really needs cutting, Ron. It's so dry. I could start like a localised bushfire. Just...
I've never been wetter, to be honest. is so hot in this flat.
I don't think that phrase should be... Someone was literally asking me yesterday, is this podcast suitable for children? And I said, it depends. Like, we don't do any graphic content, but we do sometimes swear. But now you've just bummed that up the wall.
Yeah, I'm a one-man swamp at the moment. It's so hot, and we can't open the windows because of the cat.
Get the nets for the windows, Ron. You cannot go a whole summer living in an attic with closed windows. You're going to die.
I slept on the floor in the office last night.
What's wrong with you? Just get the net things for the windows. You can't let a cat dictate your life.
I already do.
Yeah, you need to change it, Ron. I'm starting an intervention now. The cat will be fine. Just put a net on the windows.
Okay.
What are you worried about? That the cat will, like, get really into fishing?
No. It's I don't even know. It just seems like a big to-do.
Oh, my goodness.
Okay, question 1 for 1 out of 5 points. Carefully counted 5 points. Why are the noble gases inert?
Because inert is a good word, isn't it? Because they have very full outer rings.
Very full?
Yeah. As full as they can be.
Yes, okay.
Very full.
Or as you might have wanted to define it, just full.
Well, I wanted to make sure you extra knew I knew what I meant. Very
And why does that mean that they are inert?
No space at the party, bro. This party is full of electrons. So other ones that are looking to give away an electron, the noble gases are like, nah. Guest list only.
They're isolationists. They don't need anybody else's electrons, and they also don't need to get rid of any.
Yeah.
Correct. Okay, that's 1 point. Question 2.
Oh, but I gave 2 answers there.
Yeah, it was all one.
Oh.
All 1 point, because it was quite easy. Question 2, though. 3 points on offer here.
Okay.
What is the balanced reaction equation of lithium reacting with fluorine? Is that Mackie scruffling around on the floor around you?
Well, she's actually downstairs. She'll be sitting at the bottom of the ladder to my office, just gazing up. It sounds like she's found a toilet roll holder or something somewhere. What was the question, Ron? This just isn't ringing a bell, and not a single bell.
What is the balanced reaction equation of lithium reacting with fluorine?
Mate, I can't remember this at all. 12? Is this with the triangles? Is this where the triangles came in? Was that this?
That was episodes ago, I think.
Shit.
That was physics, so yeah, that was like 3 episodes ago.
So lithium is 3. Fluorine is 9. The best I've got is 12. I can't remember doing this. Lithium and fluorine. Oh my god. I don't know, Ron. I just can't even hazard a guess. 12. That's all I've got. I don't know.
So, let's not think about trying to write the equation of it.
Good,
but
'cause I can't
what do you
remember.
think would happen based off your knowledge of electron shells and that?
Oh wait, is this where 2 buddies have to become 1 buddy? Is that this?
I think you're hinting at it,
Yeah. All right. So lithium, if that's a number 3, that means it's got a ring of 2 and then a spare 1. And then fluorine being a 9, that's got a 2. And then a 7, so it's got 1 space. So it's just 1 lithium and 1 fluorine. They're buddies.
But fluorine goes around in a pair?
There's no way I could have known that.
There is, because last week when we spoke about this, and I know this because I've just edited this episode. So I know that you went, oh, there's no way I could have known that if you're not going to explain why. And then I explained why. So
Why is it?
I can't tell you that.
Oh.
That's question number 3.
So 2 fluorines and 2 lithiums.
Okay, you're not going to get there. So,
Nah, I can't remember this. This is too stupid again. We've strayed into stupid territory.
remember from last week,
No.
if the numbers before the element, that's how many there are. So it's 2 Li, 2 lithium, plus Fl2. That little 2 afterwards means that they're in a molecule together that has 2 of them. And then they make 2 lithium fluoride, LiFl. We did this exact equation, but we did it with sodium and chlorine last time.
Well, it's not the exact equation then, is it?
Well, it is, because remember how for about 3 months now we've been talking about how groups, up-downers of elements work in the same way.
Yeah. Nah, I just don't remember that at all. I'm not sure I did that.
You did. So that's a 0 out of 3 for Laura there. For those gambling along at home, it's a point. I'll give you a point for 2 Li, a point for Fl2, and a point for 2 LiFl. Ready for question number 3, Laura?
No, I'm not doing very well.
No, you're not.
I can't remember any of it. Where's it gone?
You didn't listen great last time, and it's not so much your fault.
Yeah.
You kind of had the feet equivalent of those squishy things you could buy from Hawkins Bazaar that you can't hold on to.
Oh my god, Ron, they've got worse. My toenail has entirely fallen off.
Just keep it to yourself.
It's so disgusting. It looks like a chewed sausage.
So question number 3.
You know the cuticle on your nails, like that little half moon thing? Did you know that's like a little pillow of skin underneath?
So question number 3 is, why do halogen elements form molecules of 2 atoms? The specially requested piece of information from last episode.
Why do halogens,
Group 7.
group 17, do what now?
Form molecules of 2 atoms. Why is it Fl2 or Cl2? Not just one
Oh,
chlorine?
because they're lonely. They got a lonely boy. They don't like to be lonely. Yeah. They hate being reactive, so they just incest it up instead of looking for a different buddy.
Explain it.
I am! That's an explanation you just heard. Yeah, that. They've got an extra electron. Sad boy. I'm so aware of the fan of your computer.
Yeah, it's so hot.
Open the window then. There's no cat in that room with you.
Okay, shut up for a second so that we can edit this out. There we go.
Oh, I can hear the rain now.
It's nice, isn't it?
Is it getting on you?
It's splashing on me, but I'm kind of loving it.
No, you're double swamped.
I'm on 3 showers a day.
Ugh, you dirty boy. Well, actually, I suppose you're clean. Oh, God, Ron, I don't know. Yeah, it's that. It's what I just said. They have an extra electron and they don't like it, so
They have no preference at all. They are not lonely, and they don't prefer it one way or the other.
Well, they do, otherwise they wouldn't do it, would they? Oh, Ron. This is wet.
The
All right.
weather here.
I don't know how to describe things out of those terms. They've got an extra electron, and it, just for no reason, they want to be... they get in a pair for no reason. This is a disaster. Your house is flooding. I can't describe things without emotions. They just get in a pair, Ron, rather than be alone. And that's not about feeling lonely. Alone is a thing that is a thing.
Okay.
So they get with their own kind.
But what likes to be in a pair?
The electrons.
Okay.
The atoms. The molecules.
I'm going to give you half a mark.
Oh, okay.
Just for the... I think you get it, but I think it was just so incompetently explained that I cannot in good faith give you a full mark.
Feels like we've put the rain in to to articulate how I'm feeling.
Yeah.
Do you hear that sound? That is the sound of girlfriend of the podcast, Judith, flapping herself silly.
Masturbate.
It's Ron shuffling top trumps. We're going to play a little bit of Elements top trumps. Ron, that episode really fell apart towards the end there. We gave up on each other and science, I think. Oh, you're dealing all the cards. This is going to be a long episode, buddy. Okay, so these are Stephen's top trumps that he gave me. Also, just before we get distracted with the top trumps, I will just say I will be accepting images of Xenon Warrior Princess on all social medias and to our email address, lexeducation@gmail.com. All right, Ron, I'm going first. So I'm looking at my thing. The options on my top trumps are melting point density, price, discovery date, and size of atom. But I don't know what of these... I don't know what this element would be impressive in. This is a problem.
I think I'm going to win this handily.
Oh, yeah. With discovery date, we're thinking earliest is the better, aren't we?
Yeah.
No, I'm going to go with melting point. Minus 271.
What wins, higher or lower, melting point? Higher, I guess.
Surely higher.
Yeah, 115. Why did you go for a minus number?
Well, I thought lower. I thought...
Why? Then it's just a liquid or a gas or something.
Oh,
Give me that.
right. Ron wins helium.
I just said that makes more sense.
Yeah, girlfriend of the podcast, Judith, is on my side.
Well, if it
It's
melts
absolutely
really easily.
nonsense. Melting is about hot, so the hotter the better.
The hotter, the wetter, the stronger, the better. That's a catchphrase, babe. Have you been listening to the podcast?
No.
You're such an asshole.
Okay, I have the same options because it's top trumps. My picture has a picture of some very green bananas on it.
I think I've got a solar panel on mine.
Oh. What could that be? I'm going to say... I have no idea. Density, 862.
Oh, nuh-uh. Hang on. Is it more dense or less dense?
More
What's
dense
good?
is better.
Okay, 1,873. Cesium yorcardium. I had
Nice.
cesium. Ron had potassium. Yeah, bananas, potassium. We're learning, we're laughing, we're learning. Oh, yeah, I've heard of this one. Oh, I'm going to go density here then. Density... 8,650.
Density 10,500, little
Whoa!
bitch.
What's more dense than cadmium?
Silver.
Ow!
It's my turn now. That's why nobody's saying anything. This is shit. What a shit element.
What is it?
Oxygen. You bloody
I was
useless.
going to guess it was oxygen.
Size of atom, 304.
346.
Damn it.
Just beat you with old magnesium. Well done, Maggie May. All right. This one is said differently across the Atlantic. It's not a good one, though, I don't
Mine
think.
has a picture of a thermometer on it.
I've got an aeroplane. I'm going to go melting point 660.
Yeah, shouldn't have told you it was mercury, a liquid at room temperature.
Whereas aeroplanes, I learned this in the National Treasures podcast, my other podcast, sorry to cross-pollinate, that aluminium being the body of a Concorde is the reason Concorde was limited to a speed of Mach 2, because above that the aluminium gets too hot and starts to melt. I'm full of facts. It's me again. Right. Oh, this has got a very high melting point. I'm going to go with that. 1,538.
Sorry, I wasn't listening. Which one?
Melting point.
Yeah, you win.
You can't melt iron, bitches.
You can melt arsenic.
Oh, arsenic? That's not on the periodic table.
Yes, it is.
I didn't see it on mine.
It's there.
Ah. Well done, science. Ooh, I've got a crop duster here. It doesn't look good. Whoa, arsenic was discovered in 1250. I am having a good time. This one's
I can't wait to see the listener stats for this part of the episode.
It's not a good card, this one. Let's go. It's very cheap. There's a price on here. I've not used it once because I've got no sense of how expensive an atom should be. Oh no, it's per 100 grams, not atom. I'm going to go size of atom 370.
420.
Oh, you get bromine.
Okay. Christ. There's nothing good about this one.
Is it the element Ron?
Slam. Size of atom 350.
384! Boron! Boron beats chloron. Who's this? Oh, Richard Osmium. I'm gonna go price. £16,000 per 100 grams.
God damn it, £15,000.
Oh, Europium, come to me. We had some spenny cards there. This one's
your favourite
garbage.
element?
This one's absolute garbage. I've got nothing here, Neon. Discovery date, 1898.
1807. Okay, right. Discovery date, 9000 BC.
Whoa, yeah, you take some nitrogen off me there. What was that? Copper, yeah, the Copper Age.
Discovery date, 30,000 BC.
Jesus, no, what? Fluorine?
Carbon.
Carbon.
Density, 11,350.
0.1. You can take hydrogen. Oh no, I'm down to 2 cards.
Only because Tom's stolen. Yeah.
Oh. How do you win Top Trumps?
You get them all. We're not playing the whole game.
Oh, right.
We
We're just going
can't.
through the
We
cards.
can't do that.
We'll do that on the Patreon.
This has already been far too long. Size of atom, 462.
Damn it, 364. Take my lithium. Okay, final card. Come on, we want to win this one.
You should take your lithium. Discovery date, 3000 BC.
Piss, 1669.
And that's a win for Ron.
Yeah. All right. Well, thank you so much, Stephen, and thank you, listeners. If you're a silent lurker or a chatter, we love you.
If you're still there.
We love you. Let us know if you did listen to the end of the Top Trumps. I'd be fascinated to know. Let us know if you unsubscribed as an outcome to this game. Let us know if this is the reason we got that many 1-star reviews this week. Listen, we'll see you next week for physics.
Physics.
The first non-argumentative
The
physics.
most amicable physics you'll ever hear.
Bye.
Class dismissed.